Okay, today's lesson, if I go to the top here, it is about parent functions, domain and range. And the new folder that we're in is called transformations. Basically what's like this. You take a function like that parabola here, the x squared graph, and then let's say that I want the thing to move up to. How do I get what do I do to the equation to get it to move up to like that? You just do plus 2 after it. Okay. How do I get this parabola to flip over though, so that it's upside down? So it would look like this. And you know what to do? Sir? Yes, a negative on the function would make it flip over. Negative x squared. Now, some of you are like, that don't understand the order of operations. They're like, but wait a minute, negative x squared would just be the same as x squared. No, because the negative in front of it isn't in the parentheses that you'd have. The parentheses for an x squared are just the x. So that's flipped. All right. So back to, let's make 5 little pictures. That's one of them. Who remembers what the square root graph looks like? Anybody? This is one of the ones that's tougher for kids usually, so don't feel too bad. All right, here, draw this. It's kind of like a ramp that's going up as you go from left to right. And let me tell you why. If I stick in 0, I get 0. Think about it. 0, what's the square root of 0? It's 0, because 0 times 0 is 0. If I stick in a 1, what's the square root of 1? It's 1, so 1 comma 1 is on your graph. If I stick in a 4, do you get what I'm doing here? If I stick in a 4, it's the square root of 4, which is 2. So I go over 4 and up 2. Get the idea? That's how the square root graph goes, and it just keeps going forever that way. All right, so that's what the square root graph looks like. Does anybody have the absolute value one? Usually there's somebody. Yes? I agree. I would call it a V shape, like that. That is your absolute value graph. Now, if you're like, well, where are you getting this stuff? Well, once again, I can just put in points. If I want to make an XY chart for it like this, I could figure out any of these. In fact, if I was an evil genius and was going to lock you in here and you can't go to lunch until, okay, first of all, I could get fired for that, so I'm not going to do that. But if lunch is actually such a big deal at school that if they don't serve you a lunch, they can't call it a school day. Did you know that? It's true. So if, for instance, the kitchen has a problem with its water supply and they can't serve a lunch, then they will dismiss because they can't have a school day if they can't have a lunch. They can't just, sorry kids, no lunch today. If they can't serve a lunch here, it's not a school day. Anyway, so I'm not going to keep you in here without lunch until you figure it out. But if I did, how could you do it? You could just make an XY chart for all of them. I don't know what that looks like. I can make an XY chart and figure it out by going, I'm going to stick in 0. What's 0 to the third? 0. What if I put in 1? What's 1 to the third? 1. And what if I put in 2? What's 2 to the third? And I just graph all those points. If I just graph all those points, connect the dots, you'll know what it looks like. Okay, so it's not like you have to truly have these all memorized. If on the test you forget what x to the third looks like, you can just do what I just did. Stick in some points. Hint, word to the wise, always throw in some negative points too, like -1. What if I put in -1 on my list? What's -1 to the third? -1. So -1 and -1 is a point on that graph. Okay, so you can always recreate these by making an XY chart. Okay, remember that. You know why I put this on the top 20? It's because it can graph anything. Even if you get a really complicated function, you can always stick in a number, figure out the point, stick in another number, figure out another point. You can graph anything with this. That's why it's on the top 20. All right, so back to, do you know what this guy looks like? X to the third, I just showed you a few points, but do you remember that one? Miss M? That is correct. It's like this. It goes through 0, 0, and you can know that because if you put in a 0, you get 0. It goes through 1, 1. Most functions do, because when you put in a 1 here, you get 1. It also goes through 2, 8, because when you put in a 2, you get an 8, and that's like way up here. And it also does some negatives like that. There we go. There's my x to the third graph. And the last one, this one, I don't know. Not many people know this one. But 1 over x, does anybody have it memorized? You've actually seen it before? Yes, sir? You are half right. It is like this, but it's also like that. It's got a left and a right part to it. And why would I call it the butterfly? It's a stretch, but if you put these together, it's sort of like the wings of a butterfly. Or here's his little antenna and his body, and then he can fly away. Okay, anyway, there is your 1 over x graph. That's the toughest one today, other than a circle. But circles are actually, I think, a lot easier. Because you all know what a circle looks like. If I just say, what's a circle? You guys know what it looks like already. You didn't know what that looked like. Only one person, maybe. But a circle is the last one. It says, sketch the graph of a circle. You all know what a circle looks like. If you don't, we've probably moved you out of honors. All right, so there's a circle, but do you know the equation for it? That's the harder thing. Does anybody know the equation for a circle like this? I would have to tell you one more thing to be fair. If this radius here, this distance, if I told you that radius was 4, could anybody tell me the equation for that circle? Well, you're not alone, because on the last PSAT test, that was not the number 1, sorry. It was in the top 5 of the most missed questions at Minnetonka High School. Nobody knew the equation for a circle. I shouldn't say nobody. Very few knew. Here it is. It's really easy. X squared plus, take a guess, y squared. And now I bet you can even guess this part. R squared, which is in this case 4 squared. That's the equation for that circle. X squared plus y squared equals 4 squared. That's how you get a circle. Now you might be thinking, okay, so how am I supposed to get points? Take a wild guess. XY chart. I said it works for everything. It does. So let's stick in 0 and see what happens. If I stick in a 0, we would get 0 squared, which is really like nothing, right? So then it's really y squared equals 4 squared. So then y must be 4. And is 0, 4 a point on your graph? It is. And even better, there's actually 2 answers that will give you 16. See, 4 squared is 16, right? 4 works, but what also works? -4. And so 0, -4, you get a point here and a point here.
Can't you do -4 and 4, 0?
So if we wanted to make them, okay, can we also do 4, 0? Yes, but that's sticking something in the y. For right now, I just wanted to put in something for the x and see what came out on the y. But what you just said is right. This spot, 0, 4, is also a point that works. How do I know? Because I can just put it in and see what happens. If x is 0 and y is 4, that works. How about reversing them? 4 over here, 0 over there. Totally works too. You know what I'm saying? That's why 0, 4 and 4, 0 and -4, 0 and 0, -4 all work. Anyway, I don't need you to know all that much, but here's a typical PSAT question. Let's see if you could be one of the kids that actually answers it right now. What shape is it, and what do you know about it? Yes? Circle radius of 5. Very good. And if I was going to make it more advanced than that, let's say that they decide to make it this kind of question but a little bit harder, I could say, Now the radius is still like it was before, so it's square root of 16, it'll be 4 radius. But what's happened to my circle? It's moved. It's moved where? Not down. It's messed with the x. If it messes with the x, that's not going to move it down. It's going to move it to the left or to the right. And in this case, it's to the right. And this whole unit is about that kind of stuff. I know that feels weird. I know -2 seems like it should be to the left. But you're going to understand this in a few days. You're going to be like, oh yeah, of course, it's to the right. It's the opposite of what you would think if it's on the inside. I know you think I'm crazy, but I've taught this a long time, and I guarantee you that moves to the right 2 places, even though it seems like it should be to the left. All right. And I can even prove it with this. Let's say we want to find a point on this circle. Do you get, I can just stick in numbers until I find a combo that works? Okay. So if I'm right, and my circle has been moved to the left 2 spots, here's my circle. It should be moved to the left 2 spots. It should be kind of like that, right? Then there should be a point over here that works. And that would be 0 for x, comma, something else for y. Let's see if it actually works. 0 here would make this -2 squared, which is 4. And then I'm going to subtract 4 from both sides. And this is y squared equals, I'm subtracting 4. And this would be 16 minus 4 is 12. And then I would figure out, oh, the square root of 12. 0, comma, the square root of 12. What is the square root of 12? Well, I can tell you this. It's bigger than 3. It's 3 point something. Because square root of 9 would be 3, right? That's right there. It worked. All right. So, moral of the story, this one has been moved to the left. To the right 2. I have the picture wrong. I said it right. It's been moved to the right 2. This circle should be moved to the right 2. And there's my point, 0, comma, root 12. I wish I knew what root 12 was. Could somebody use your calculator to figure out what root 12 is real quick? 3 point something, I think. Nobody's getting out the calculator. It's okay. I'm going off on a tangent now. But this is important to know. It goes the opposite direction of what you'd expect. You'd expect it to go to the left. It actually goes to the right. You'll learn more about that later. All right, so far, all I need you to know is you can make a graph with an XY chart. Circles have a weird looking equation with x squared and y squared in it. That'd be a circle with a radius of 12. And I did hint at this, and you're going to eventually need to know it. Stuff in here, inside of parentheses, goes the opposite of what you'd expect. That seems like 8 to the right, but it's actually 8 to the left. And if you wanted to see that, I'm going to show you a simpler one. This is your square root function. And what if I want to move it up 1? I think everybody knows putting +1 moves it up 1. Because y needs to get bigger. If I add 1 here, do you get y is going to get bigger? That's pretty easy. And this part's the part that's going to freak you out again. Stuff underneath here, if I say -3, it feels like that should move 3 to the left. It actually moves 3 to the right. So this guy would be moved 3 to the right and up 1. That's a little preview of what you're going to have like on day 3 or 4 of this unit. I like to, it's called pre-teaching. I teach you a little something that you don't totally understand yet. It actually is, it's been proven to work to help you understand it better when we get there, because your subconscious is actually listening to me right now. It's going to be like working on this annoying little dilemma that's going opposite of what you'd expect. Okay, so then the last thing I have to teach you is about how to find domain and range of functions. So this is a big day, actually. Normally you don't have to learn this much in one day, but we're going to get it. That spot right there is, I just said I moved it 3 to the right and up 1, so that's 3, 1. If that spot is at 3, 1, the domain of a function is all of the x's it can be. The range of a function is all of the y's that it can be. And we usually just put them in parentheses like this and say it can be from this to this. Well, this function here starts here and goes forever this way. And I said forever. That means its domain is from 3 to infinity. Why not 2? Watch what happens when I put in a 2. 2 minus 3 makes -1. Can you have a square root of a -1? No. That's why you can't use 2. You have to start at 3. Is it okay to put in a 3 even? Yes, because 3 minus 3 is 0, and that isn't, it's okay. Square root of 0 is a thing. It's just 0. And then we add 1, and it goes up and hits right there. Okay, so the domain's from 3 to infinity. Which one of you geniuses can tell me? And there are a lot of smart kids in here. And genius might be a stretch. You know what IQ level you have to be at to be considered a genius? If you don't know that, you're not a genius. Anyway, now I'm just teasing. You could actually be a genius and not know the IQ level required to be a genius. But 130 is the typical IQ of our past presidents. You know, like for instance, Obama went to Harvard. Prior to that, we had Bush who went to Yale. I mean, they're pretty smart guys. Okay, but 130 does not qualify you for a genius. It's got to be like 140, 150, and there is argument about what is like exactly what should be considered genius. But if to get into Mensa, that's a special club you can only get into if you are literally a genius. And if you're interested in being in Mensa, you can apply to it. What they're going to do is give you an IQ test. And it's super secure, so you don't have your smart friend over your shoulder like telling you what the answers are. And then you can get into Mensa. And I don't know what their requirement is, but
What do they do?
what do they do? They sit around and be smart. They actually, there is a club. And to some extent, I'm sure part of it is that if you're really, really that smart, it's probably fun to hang out with other people that are that smart. And they don't like get together and go to the bar and drink. I think it's more, it's like an online, like they have a newsletter and they share issues that all, concern them. But if it isn't obvious, I'm not in the club, so I don't know for sure. Maybe they do really cool things. I am not. Let's just say I think I could have been a president, but I am certainly not a genius. All right. So the range. The range is kind of like the domain thing, except it's for the other direction. Could you tell me the range? Somebody in here can. It's about the y's, yeah. What do you think, Jay? I know. It's on the video, so I'm going to just not use your name. Okay. You say 1 to infinity. Now, some kids are going to argue with you and say it's supposed to be 3 to infinity. What do you think? Is it the 1 or 3? It's the y value. Would you agree that's the y value? So it goes from 1 to infinity is correct. Now, one more thing. At the first, when I introduced this, I just put them in parentheses because you aren't used to this notation at all. Now I have to make you a little bit smarter. That 3, can it actually touch 3? Can I put 3 into this function without the function dying? Can it be 3? Yes, it can. So if it can be a number, it's kind of like saying less than or equal to. If it can be that, you have to put brackets on that number. Not a parenthesis. Brackets on the 1 because it does get to 1. It touches 1. So I know some of this is going to bother some of you, but that's like the difference between less than or equal to or just less than. If I say some number has to be less than or equal to 8 versus some number has to be less than 8, do you get that this one can touch 8 and this one can't? It's like that. You're saying that with these brackets. With a bracket, you're saying it can touch 3, and then it goes up from there. And this can touch 1, and it goes up from there. That make sense? All right. So what if I said this, from 2 to 5, and I put a parenthesis or in a bracket there? What would that mean? Between what and what? Don't overthink this. It's between what two numbers? Between 2 and 5. But then, what does the bracket mean that the parenthesis doesn't mean? It can touch 5. So it's bigger than 2 and up to 5, and it can be 5, but it can't actually be 2. So if I was going to put this on a number line, I'd go like this. Here's 2, here's 5. It can't be 2, but it can be 5. It would be kind of like the numbers in between 2 and 5, but it can be 5, but it can't be 2. Does that make sense to you? That's the brackets versus parentheses thing. So much to learn today. All right, and now one more. Let's see if you can tell me if I make this V shape, except I'm not going to just put the absolute value at the origin where it normally starts. I'm going to shift it to the left. I'd like you to tell me if its lowest point right there is at -4, 0, what's its domain and its range? And by the way, oftentimes people ask me, is this supposed to go forever? I'll put arrows on the end of it if you ever ask me. And yeah, they go forever. So now, what's domain? What's range? I want to pause while you try to answer that one. Okay, I hope you know domain is this kind of a direction. It's this way. Do you agree this thing goes forever in both directions and therefore would be negative infinity to positive infinity? At least now that you see it, does that make sense to you?
Yes.
All right. Domain is it goes forever in the x direction. This kind of direction, it goes forever. All right. Now, how about the range? Does it go forever up and down? No. It goes as low as what, and then as high as what? What's the lowest it goes? 0. A lot of people think it's the 4, but it's not. How low is it? It's at 0. It's 4 to the left. But its lowest point is at 0 to infinity. And this is important. I just taught you this a second ago. Does it touch 0? So it's a bracket at 0 because this function touches 0. You can never touch infinity. MC Hammer's favorite. Can't touch this. Okay. Yeah, I got to get some parachute pants for that next year. All right. So, do you understand this one? Because I'm about to move it up one last time because the last thing I have to teach you is about the weirdest function, that butterfly function. It's got a weird domain and range. I'm going to do one more normal one first, just to see if I haven't lost you all on the easy kind. Here's a parabola, but it's been moved a little bit. It's got it's at 2, 1 here. It's over 2 and up 1. What's its domain and range? Don't have to draw the whole picture. Just give me a quick DNR. Did you say that this is negative infinity to positive infinity? Raise your hand if you had that one right. Good. Can you touch the infinities? No, can't get there. You can go forever and you never get to infinity. All right, next, range. How low can you go? I think that's a song, isn't it? Anyway, it can go as low as, not the 2. These are about the y's. Look at that number. 1 to infinity. And does it touch there? Yes, it does. Bracket, parenthesis. Raise your hand if you had that one right. Good. Now, this last one's going to bother some of you. It's domain and range of this weird one that looks like this. Now, this is the only function that has this property that it gets closer and closer to 0, but it'll never touch it. Do you get, as I go further down, it's going to get closer and closer to the green line, but it can never actually touch the green line. Here's the way I would think of that. It's kind of like, let's say that you have your pool in your backyard, and you dump some red paint in it, and your water turns all red, right? And you drain it out, and then some of the red sticks to the side of the pool, right? Put in more water. Is the water going to be completely pure yet? No, it's some of that that's going to wash off the sides of the pool, and that it gets a little bit better. It drain out the water again. Could there still be a little bit of red left stuck to the sides of the pool? Yep. You're ever going to be able to get every last molecule of red paint out of your pool? No, you can get closer and closer and closer and closer, but in theory, you couldn't ever get to zero. It's kind of like purifying water. Okay, you take some really nasty water out of a swamp and you purify it once, just run it through a purifier. Is it completely 100% pure? No, it gets a lot better. Could you take the purified water, run it through a purifier again? I think you get where I'm going here, but it's still not going to be completely, perfectly pure. The filters aren't that good. It says on them that they're going to be 0.99 or whatever. You can never get to zero, like zero contaminants. The air that we're breathing right now, it's got nasty stuff in it. Okay, is it enough to kill you? No. School tries to make sure that it's, safe air, okay? But what if we run it through a purifier? It'll be better. Is it going to be perfect? No. You can't get to zero. There's a lot of things that are like that in the real world. All right, so this function cannot touch zero in this direction or in this direction, and I call those things asymptotes. I didn't make up the name. It's a math word. It's been around a long time. Okay, you can't get to those. It's kind of like an electric fence that it won't cross. It'll get right up to it, but it won't actually touch the fence because that would electrify it. Here's another way to think of it. Y equals 1 over x. Do you get if I put in a really, really, really big number there, it would be 1 over like a million, and it's getting close to zero, but it'll never be zero. You cannot ever make this equal zero. It's impossible. The closest you ever get is 1 over infinity. But you can't actually put infinity in this, can you? Because you don't know how big it is. And so therefore you can never make it equal zero. All right. How about the other way around? What if I don't want that to equal zero? What if I wanted to put a zero right there? You can't use x is zero, because then it'll be 1 over 0. I hope you've been told in the past, haven't you, that you can't do that? That's illegal. 1 over 0 is illegal. You type it in the calculator, it's going to say error. It won't say illegal. Yeah, you're busted. The math police come and drag you onto the station. Just to clarify, is 0 over 1 okay?
Yes.
It is. It's just 0. This one's okay. This one, illegal, arrested by the math police. Or the world ends, and it turns out it's the 23rd. So maybe on Saturday you should try dividing things by 0 and see what happens. It might cause the whole world to end. All right. So anyway, these asymptotes, they're going to ask you for what they are, and I need to tell you. They're called the horizontal and the vertical asymptote. I hope you know the difference between the two. If I had trouble with memorizing those for a while. Horizontal is like the horizon. It's that pink one. Okay, so this is the horizontal asymptote. And this can get a little confusing because it's the opposite of what you'd think. Wouldn't you think, since that's the x-axis, that would be the spot x equals 0? But it's not. It's the line what? Y equals 0. The x-axis is y equals 0. I know, some more brains just exploded. I have to get some paper towels out. The x-axis is y equals 0. Think about it. It can't be x equals 0 because look, right here, that's where x equals 1. That's where x equals 2. That's where x equals 3. X is a whole bunch of things. On the x-axis, it's a whole bunch of things. So what's y always, though? 0. So that line is y equals 0. And this, which is called the y-axis, is the green one. It is where, what do you think? X equals 0. And that is the vertical asymptote. If I were you, I'd write these down because they're going to ask you them in the homework quiz, and at least you can have one right. Okay, vertical and horizontal asymptotes. So what's the y-axis? It's where x equals 0. What's the x-axis? It's where y equals 0. And those are the horizontal and vertical asymptotes. Okay, and the last thing I have to teach you, thankfully, and we'll still have 10 minutes left, is what's the domain and range of this guy? Well, it's kind of weird because it sort of goes forever in both directions, but Not exactly, because it's got this little hiccup in the middle. So what is the domain and range of this? I am just going to give it to you and see if it makes sense to you. I can't just say from negative infinity to positive infinity, because the one thing it can't ever be is what? 0. So how do I write that? I say it goes from negative infinity until it hits 0, and then if I put a bracket, it would mean it touched 0, so I don't do that. I say that, but that's only half of its domain. It also starts up again after 0 and goes further, so what do I put then? Somebody can do this, come on. 0. No, that was negative. There you go, that's it. And the only other thing is, and this is just a little notation thing, I don't know if they'd mark it wrong with the Schoology quizzes. Maybe they have it both ways. But technically, you're supposed to have a U for union in between the two. So negative infinity and positive infinity has this little glitch. It can't be 0, so you got to write it in 2 chunks. Up to 0, and then from 0 on. I know that's strange. I'm going to give it to you as a number line also. Here, if it can't be 0, but it can be everything else, it's kind of like this. That's a pictorial representation of the domain. It goes forever, and everything works except 0. I kind of like this one better. And you can write this one, but it's going to be very hard to type that into Schoology, isn't it? Okay, so for the Schoology quiz, you need this one. The domain is from negative infinity to 0, union 0 to infinity. The range is the same exact thing, because it's going the other direction. You got the same problem. It goes forever down, it goes forever up, and it can't be 0 along the way. So the range is identical. You can just copy that sucker down for the range. It's the same thing. It goes from negative infinity, hits 0, stops working, starts up again after 0, and goes to positive infinity. It's just doing it in this direction. All right. I know it was a lot. That was too much, in fact, but it's the way it was. So now, your homework for tonight. It's a Schoology quiz. Remember how I do those. Don't be paranoid about, oh, it's going to mark this one little thing wrong, and it's going to make it look like I don't know what I'm doing, but I'm just trying to type it in. I'm not going to mark you down for those. As long as you have a decent score on it, I'm going to give you the full credit. And if you do a bad enough job that you think you should do it over again, well, do it over again, and I'm sure you'll get more, and then you'll have a decent score. Decent has not been defined, I know, but it depends on the Schoology quiz. Some are super easy, some of them are super hard. So have a decent score, and I'll give you 10. All right, so that's it, and you now have a Schoology quiz for the rest of the time. And now, please tell me, you have a short-term memory. If you hit this on the ACT test, what do we know about this thing? It's a circle, and how big? Radius is 10. There you go. Good. And if I wanted to do this, it would move it not down 8 like it seems. It would actually move it up 8. Because it's on the inside of a parentheses. You'll find out more about that next week. That's all I got for you for today.